The set data type is an unordered collection of unique elements. The collection is mutable insofar as elements can be added and removed from the set, but each element must itself be immutable, very much like the keys of a dictionary. Sets have a literal form very similar to dictionaries, again delimited by curly braces, but each item is a single object rather than a pair joined by a colon. Note that the set is unordered and of course has type set. Recall that empty curly braces create an empty dictionary, so to create an empty set we must resort to the set constructor, with no arguments. This is the form that Python echoes back to us too. The set constructor can create a set from any iterable series, such as a list. Duplicates are discarded. In fact, a common use of sets is to efficiently remove duplicate items from a series of objects. Here we remove duplicates from the list 1421799, resulting in the set 12497. Naturally, sets are iterable, although the order is arbitrary. Membership is a fundamental operation for sets, and as with the other collection types, is performed using the in and not in operators. To add a single element to the set, simply use the add method. Adding an element that already exists has no effect, and neither does it produce an error. Multiple elements can be added in one go from any iterable series, including another set, using the update method. Two methods are provided for removing elements from sets. The first, remove, requires that the element to be removed is present in the set, otherwise a key error is given. The second method, discard, is less fussy and simply has no effect if the item is not a member of the set. As with the other built-in collections, set sports a copy method, which performs a shallow copy of the set, copying references but not the objects they refer to. As we have already shown, the set constructor may also be used. Perhaps the most useful aspect of the set type is the group of powerful set algebra operations which are provided. These allow us to easily compute set unions, set differences, and set intersections, and to evaluate whether two sets have subset, superset, or disjoint relations. To demonstrate these methods, we'll construct some sets of people according to various phenotypes. Olivia, Harry, Lily, Jack, and Amelia have blue eyes. Harry, Jack, Amelia, Mia, and Joshua have blonde hair. Only Harry and Amelia can smell hydrogen cyanide. Harry, Lily, Amelia, and Lola can taste phenyl thiocarbamide, or PTC. Mia, Joshua, Lily, and Olivia have O-type blood. Amelia and Jack have B-type blood. Harry has A-type blood. And Joshua and Lola have AB-type blood. To find all the people with blonde hair, blue eyes, or both, we can use the union method, which collects together all of the elements which are in either or both sets. We can demonstrate that union is a commutative operation, that is, we can swap the order of the operands, using the value equality operator to check for equivalence of the resulting sets. To find all the people with blonde hair and blue eyes, we can use the set intersection method, which collects together only the elements which are present in both sets. This is also commutative. To identify the people with blonde hair who don't have blue eyes, we can use the set difference method. This finds all of the elements which are in the first set which are not in the second set. This is non-commutative because the people with blonde hair who don't have blue eyes are not the same as the people who have blue eyes but don't have blonde hair. However, if you want to determine which people have exclusively blonde hair or blue eyes, but not both, we can use the symmetric difference method. This collects all the elements which are in the first set or the second set, but not both. As you can tell from the name, symmetric difference is indeed commutative. In addition, 3 predicate methods are provided which tell us about the relationships between sets. We can check whether one set is the subset of another set, using the isSubset method. For example, to check whether all of the people who can smell hydrogen cyanide also have blonde hair, use smellHCN.isSubset blonde hair. This checks that all of the elements of the first set are also present in the second set. To test whether all of the people who can taste phenyl thiocarbamide can also taste hydrogen cyanide, use the isSuperset method. To test that two sets have no members in common, use the isDisjoint method. For example, your blood type is either A or O, never both. We encourage you to experiment with these methods and become comfortable using them. They can make for some very elegant solutions.